ultimately, a muscle has to produce tension and it has to change length in order for us to have normal motion. Well, that is a trickier thing to do than you might think. If we sometimes think of muscle in an oversimplified way, where like the brain says, okay, bicep contract, and that's what happens. Well, it's a little more complicated than that. The bicep, we'll pick on that one as an example. While it is one organ, it is divided by the nervous system into a variety of separate bits that we call motor units. Okay? So a motor unit, one motor unit, where's my definition? One motor unit is all of the muscle fibers controlled by a single motor neuron. All right, so a little refresher. Remember, you've got cerebral cortex is controlling all of our motion. We have upper motor neurons that go from brain to spinal cord. Lower motor neurons go from spinal cord out to muscle. Right? Sound familiar? Okay. So when we talk about innervation here, we're talking about lower motor neurons. All right, so from the spinal cord to the muscle. So a motor unit is all of the muscle fibers innervated by a single motor neuron. Now, the arrangement of the fibers in the muscle is not random. They're all mixed up. In other words, they come in clusters. So like motor unit 1 is this kind of salmon color, motor unit 2 is this blue color. And you can see that they're sort of mixed together. This is important for how this functions, because what the brain uses these motor units for is to, number 1, control the tension in the muscle, and number 2, improve the stamina of the muscle, how long it can stay contracted. All right? So we have many motor units in all muscles. Now, and we'll talk a little bit more about how these work in a second. Muscles vary in their motor unit arrangement, okay? Muscles that are very strong but have very little fine control, they have few motor units, each with lots of fibers, okay? So think about, we were picking on the gastrocnemius, right? It's a muscle like that. It has few motor units, each with lots of fibers. Why? Because it's a big, strong muscle, but it doesn't have to do anything precisely, right? Now, the opposite is the muscles that control our fingers, right? Many of you are typing right now. Very delicate, very high precision activity. So the muscles or the motor units that control your fingers, there's a lot of motor units, each with a small number of fibers, okay? Because remember, each motor unit has a motor neuron. The more motor neurons you have, the more control the brain has of that muscle, right? The brain needs control of high precision muscles. It doesn't need much control of high strength, low precision muscles, okay? So we have these two different kinds of things. So like an eye muscle, for example, has lots of motor units, each with only a small number of fibers, because it has to move quickly and weakly, but it doesn't have to, or it has to move quickly and precisely, but doesn't have to move anything heavy. All right, the other benefit we get is the stamina part. The body can turn on and off these motor units sequentially to kind of spread the load. So remember, a skeletal fiber, it can't stay contracted forever, right? Remember, ATP, muscles consume vast amounts of ATP, right, to make the cross-bridge cycle happen. Well, one of the limits on how long a muscle can stay contracted is how long the ATP lasts and how much blood supply there is to supply new ATP. All right, so the way that motor units can help with this is the brain can turn on motor unit 1, right, and create tension. As motor unit 1 fatigues, runs out of ATP, then it's going to turn on motor unit 2 and let motor unit 1 rest, right? So it's kind of handing off the work so that by the time we get to motor unit 3, motor unit 1 is fully rested and can start up again. Okay? This is happening all the time in everything we do. Okay? Because most of the time, our skeletal muscle contractions, it's not like it's contract and stop, right? You know, like we're holding something or we're carrying a weight or we're pushing on a thing. So motor units allow the different skeletal fibers to sort of take turns, and increases the stamina of a muscle, how long it can work at its best. Now you will notice in this case, is this muscle at maximum strength at this time? It's not. Maximum strength, if you wanted to see how strong this muscle was, the brain would activate all the motor units at once, right? And everything would contract. But then you've lost your stamina improvement, because when they're all fatigued, the muscle gives out. See? So it's one of we see this in our exercise routines, right? You know, like if you lift as much as you can possibly lift, you can't do it for very long, right? But if you lift half of what you can lift, you can hold that for quite some time because of the recruitment and the motor unit taking turns.